material in my Touch Life Scholar. In this video, we want to look at gametogenesis, but right in this video, we want to talk about the introduction to gametogenesis, and these are the sequence to follow. Then in my next videos, I'll be talking about oogenesis in details and spermatogenesis in details. Now let's get right into it. From the word gametogenesis, we can deduce that this word is divided into two, gamete and genesis. Do you get it now? So genesis has to do with creation, formation. That is what genesis is all about. So when we relate genesis to gamete, that is what creation of gamete. Just like the Genesis in your Bible you get. So it has to do with creation. So in this gametogenesis, we want to look at how gametes are formed. What gives rise to the gamete as a whole. That is what gametogenesis is all about. But before we go deep into gametogenesis, I want you to understand what we call the 3G. Yes, the first G is what we call the gamete. The second G is what we call the gonad. And the third G is what we call the genital. Yeah, so these are the 3G that we are going to lay emphasis on gametogenesis. I get what I'm saying now. So what is gamete? Gametes are those reproductive cells. You get what I'm saying? Yeah, they are reproductive cells that's made up of 23 chromosomes. They are haploid chromosomal structure. Do you get it now? That is what we call the gamete. And you know, in male and female of a reproducing species, the gamete is divided into two. We have the male gamete and the what? Female gamete. Are you getting my point now? So the male gamete is what we call the spermatozoa. Yeah, so this is the male gamete. Are you getting my point now? So the female gamete is what we call the ovum or the ova. Yeah. So those are the gametes, the male gamete and the female gamete. So let's go to the second G, which is the gonad. When we are talking of gonad is the site at which gametes are formed. I get what I'm saying now. So the site at which these spermatozoa and ovum are formed are what we call the gonad. Just like we have the male and female gametes, we also have the male and female gonad. You get my point now? So the male gonad is what we call the testis, and the female gonad is what we call the ovary. That is to tell you that this male gamete, which is spermatozoa, is formed in the testis, and the female gamete, which is the ovum, singular, or ova, plural, is formed in the ovary. You get my point now? That is about gonad. But when we are talking about genital are just like reproductive organs. You get our sex organs that are responsible for coitus, which is sexual intercourse. That is genital. We also have the male genital, which is the penis, and the female genital, which is the what? Vagina. So these are the 3G. And you need to understand this 3G because during the process of gametogenesis, it will be of use. You get my point now? So let's get into it in details. When we talk about gametogenesis, in gametogenesis, it just deals with how a diploid cells. When we talk about diploid cells, I'm talking about 2N. Yeah, this is represented by 2N, diploid cell. Diploid cell is made up of 46 chromosomes. So in gametogenesis, we want to look at how these diploid cells undergo what we call division, cellular division, to give rise to a mature haploid gamete, which is 23 chromosomes. Are you getting my point now? So that is what happens in gametogenesis. These are diploid cells, 2N, 46 chromosomes. So these diploid cells undergo a series of division, mitosis and meiosis, and eventually give rise to our mature gamete, which is represented by N. That is 23 chromosomes. That is what gametogenesis is. And you know, in gametogenesis occurs in both male and female of a reproducing species. Just like I said earlier. If gametogenesis occurs in the male, then it is referred to as what? Spermatogenesis. Do you get it now? This is the spermatogenesis. But if it occurs in the female, it is called what? The oogenesis. So gametogenesis is just the collective name for the process that is occurring in female and male. I get what I'm saying. So that is about gametogenesis. Now, if you don't forget, I said in gametogenesis, a diploid cell will undergo division, cytodifferentiation, and give rise to our mature haploid gamete. You get my point now? So these diploid cells are what we call the primordial germ cells. Yes, primordial germ cells. They are the diploid cells. It is also called precursor germ cells. Yeah, and you can also call it gonocytes. So these primordial germ cells will undergo a series of division, a series of mitotic division. There are 46 chromosomes, and they will eventually give rise to our gametes, which is 23 chromosomes. So these primordial germ cells are formed outside the gonad. Are you getting what I'm saying now? So from the gonad, from outside the gonad, they migrate into the gonad where they perform their specialized function. That's to tell you that when this primordial germ cell is outside the gonad, it is preparing for what? Gametogenesis. But their target site is the gonad, whether the male gonad, which is the testis, or the female gonad, which is the ovum. So immediately, the primordial germ cell migrates into the gonad, whether the testis or the ovary. That is when they begin the process of gametogenesis. I guess what I'm saying now. That's saying that the embryonic formation of male and female gametes is the same at one point. It means that they come from the same source. And what is that source? Primordial germ cell. And that is outside the gonad. But immediately this primordial germ cell migrates into the gonad. That is when the embryonic formation of male and female gametes behave differently. I get my point now. So when this primordial germ cell migrates into the male gonad, which is the testis, it will give rise to what we call spermatogonia. But if the primordial germ cell migrates into the female gonad, which is ovary, it will give rise to what we call oogonia. Are you get my point now? Can you start? It has behaved differently. But before, they occur the same way, which means that the primordial germ cell is coming from the what? Outside. I get what I'm saying now. So when they migrate into the male gonad, it gives rise to what? Spermatogonia. But if it migrates to the female gonad, it gives rise to oogonia. So the collective name for these two are what we call what? Gametogonia. I get my point now. So that is to tell you that when the primordial germ cell migrates into the respective gonad, that is when the embryonic formation behaves differently in male and female. That is what will lead me to my next sequence, which is extragonadal origin of primordial germ cells. We want to look at where the primordial germ cell originates from. Do you get it now? So when we talk about primordial germ cells are those diploid cells, like I said earlier, that will give rise to our gamete. There are 46 chromosomal structure. So the primordial germ cell is formed in the epiblast during the second week of development. You know, during the second week, we are called a bilaminar embryonic disc. We are like a disc. Do you remember the disc we are using to play movie at home? Yeah, that is the way we are during the second week of development. So this is the way we are in a sagittal section. Yeah, so this is it. You get my point now? So this is the way we are doing the second week of development. This is what we call the epiblast, and this is what we call the what? Hypoblast. Above the epiblast is the amniotic cavity, and below the hypoblast is the what? Yolk sac. Are you following me? So this is the way we are doing the second week of development, a bilaminar embryonic disc. This is a sagittal section. A sagittal section. But if it is where we are viewing the embryo from the top, this is the way we are doing the second week of development. So this is the epiblast, and this is what? The hypoblast. I get what I'm saying now. So this is view from above. This is the way we are doing the second week. So the primordial germ cell is gotten from where? Where is it formed? The primordial germ cell is formed in the epiblast. You know, at the caudal end of the epiblast, at this inferior end of the epiblast, there's something we call a thickening of the epiblast. That's what we call primitive streak. So cells proliferate in the primitive streak. They migrate and give rise to critical structures of the embryo. You get my point now? So that's where the primordial germ cell is coming from the caudal end of the epiblast, which is the primitive streak. So the primordial germ cell that is formed here during the second week, do you get what I'm saying now? They begin to migrate. The primordial germ cell here, primordial germ cells that is present here, they migrate from the epiblast into the what? Yolk sac. Can you see now? So they begin to migrate from the epiblast into the what? Yolk sac. Where they arrive into the yolk sac during the third week of development. Why are they present in the yolk sac? So that they can locate themselves in the yolk sac. I get what I'm saying now. So they spend some days in the yolk sac until they now migrate to the what? Gonadal ridge, developing gonad during the fourth week. Because during the fourth week, we are now like this. Yeah, so this is the way we are doing the fourth week. You know, during the fourth week, that is the process of embryonic folding. You understand later on in my course when I'm explaining embryology. So this is the fourth week of development. Now, so this is still what? Yolk sac. Yeah, so this is the yolk sac. So this is the point where we have the what? Primordial germ cells. So the primordial germ cell that is present here, I get what I'm saying, that is present in the yolk sac, they begin to migrate to the gonad. I get what I'm saying now. They migrate to the gonad. This is the gonadal ridge. Gonadal ridge. I get what I'm saying now. So they migrate into the gonad because that is their target site. That is the only region they can undergo what? Gametogenesis. I get my point now. So immediately they reach the gonad, that is when they behave the process of gametogenesis. That is when they undergo the process of what? Gametogenesis. So this is developing gonad. It is found along the what? Ingot. I get what I'm saying now. So they migrate here and they perform their specialized function, which is the process of gametogenesis. I get my point now. So that is about primordial germ cell. So that's to tell you that the primordial germ cell is coming from the outside, where the epiblast, where it is formed, the yolk sac, where it is located. I get what I'm saying, until they now migrate to their destination, which is the gonadal ridge. I get my point now. So that leads me to my third sequence, which is brief description of polar bodies. Yeah, I need to explain these polar bodies before I go into oogenesis in my next videos. Yeah, so when we talk about polar bodies are small haploid cells that are formed at the same time with an egg cell. You know, during the process of oogenesis, when the primordial germ cell that is coming from the yolk sac, when they migrate into the female gonad, which is called the ovary, so they give rise to what we call oogonia. I get my point now. So right within the ovary, the primordial germ cell form the what? Oogonia. This oogonia will undergo division. When I talk about division, I mean mitosis and meiosis. But the problem is that this oogonia divides unequally. I get my point now. So as a result of that, it gives rise to 4 daughter cells. Now, these are the 4 daughter cells that are gotten as a result of completion of oogenesis. Immediately, the primordial germ cell migrates into the what? Female gonad. So this oogonia divides unequally and gives rise to 4 daughter cells of unequal size. This one, out of this one is much bigger, while these remaining 3 are much smaller. This one that is much bigger is what we call the ovum. Ovum, this is our female mature gamete, while these remaining 3 that are much smaller are what we call the what? Polar bodies. Are you getting my point now? So the polar bodies arise as a result of unequal division of Ogonia, which you are going to understand when I explain oogenesis in my next video. You get my point now? So one funny thing about these four daughter cells that are on equal size is that they all have the same chromosomal content. Do you get? In the sense that the ovum is 22 plus S. These three are also 22 plus S. I get what I'm saying now? They are haploid chromosomal structure. They have the same DNA. They have the same content with the what? Female mature gamete. But the only difference is that this one is bigger and these three are much what? Smaller. As a result of that, these polar bodies cannot be fertilized by sperm. The only gamete that can be fertilized by sperm is the what? Ovum. So because these polar bodies cannot be fertilized by sperm, what will happen to them? They degenerate, they die off, they undergo atresia through the process of what? Apoptosis. You know, apoptosis is a programmed cell death. You get it? So they die as a result of what? Apoptosis, because they are functionless. They are not needed in the body. You get what I'm saying now? So they die off. So the only one left is the what? The ovum. Are you getting my point now? So these are the polar bodies that are not needed. But there are some situations that may arise in the sense that some of the polar bodies will not degenerate, whereby only one is left out. So during the condition, a sperm can fertilize the ovum and can also fertilize one of the polar bodies and can lead to polar bodies twinning. Do you get? They are like identical twins, a monozygotic twins, but they are half identical. Do you get? That is if the polar bodies persist. If they do not degenerate, so the sperm can as well fertilize polar bodies. Do you get? But the polar bodies cannot be fertilized by sperm in a normal way. Do you get it now? So the polar bodies does not exist in male, it only exists in female. There is no polar bodies in male. The spermatogonia will undergo division and give rise to four daughter cells that are of equal size. That is about polar bodies. Now we have come to the end of this video. Don't forget that at the end of this video, there's always a practice question. Please make sure you check it out, as it is going to help you to understand more on gametogenesis. Please like and subscribe. It's Antonio.